Okay, so welcome to this video. In this lesson, we are going to look at the matrices. We'll start looking at the matrices, and as we look at matrices, we are going to look at the following things. The first thing that we're going to look at is the transpose of a matrix. Okay. The second thing, we'll look at the multiplication, addition, and subtraction of matrices. So look at the addition. All right, addition, subtraction of matrices. Okay, and multiplication. Then the third thing which we look at is the inverse of a matrix. Inverse of a matrix. And once we are through with this, then we'll be done with matrices. So without wasting much of our time, let's start first by looking at the definitions that we need to know under matrices. We first have to know what is a matrix itself. So definition number one, matrix. What is a matrix? So a matrix is a rectangular arrangement, okay, of what? Of numbers. So it's a rectangular, okay, rectangular arrangement of what? Numbers or you can say an array, arrangement of numbers in what? In rows and columns. In columns. For example, you can have 1, 2, 4, 6. This is a matrix. It has got rows, row number 1, row number 2, and it has got what? Column number 1 and column number 2. That's what a matrix is. Now that you know a definition of a matrix, we can move to something else. Another definition number 2 to look at, we are going to define order of a matrix. Order of a matrix. What is order of a matrix? This is just the number of what? Rows and columns in a matrix. In a matrix. For example, you can have 3, 4, 6, 0, 2, 1. And I ask you to say, this is a matrix. Find the order of matrix A. What would be your answer? In short, we are saying how many rows and how many columns are there. So how many rows are here? Row number 1 and row number 2. There are 2 rows by how many columns? Column 1, column 2, column 3. 3. So this is a 2 by 3 matrix. Don't multiply and say 6. No, just leave it the way it is. 2 by 3. That would be the order. So you always start with rows, then you end with what? Columns. Next is definition number 3. A row matrix. What is a row matrix? A row matrix is a matrix which has got only one row. So it's a matrix with one row. For example, 2, 4. They're just one row, right? Row 1. So this is a row matrix. Definition number 4 is a column matrix. A column. These definitions are very important. You will see them as we get to do this. So make sure you know them. A column matrix is just a matrix with what? Of course, just one what? One column. For example, I can have 5 and 4 here. There is just one column. That's a column matrix. We are still looking at the definitions. Definition number 5. We have a square matrix. A square matrix. What is a square matrix? A square matrix is a matrix that has same number of what? Rows as columns. For example, two, 1, 0, 3. There are 2 columns here. There are 2 rows and 2 columns. So this is a square matrix. Or I can have this 2, 3, 6, 1, 5, 0, 7, 8, 1. How many columns, how many rows are here? There are 3 rows and 3 columns. This is a square matrix. As long as the number of columns and the number of rows are the same, it's a square matrix. Right. Definition number 6, we look at equal matrices. What do we mean by equal matrices? So, 2 matrices, all right, matrices are only equal. So matrices are equal only if their what? Their corresponding elements, only if their corresponding what? Elements are what? Are equal. Are equal. What do you mean? Let's say you have matrix A, 2, 4, 6, 1, and matrix B, 2, 4, 6, 1. This entry corresponds to that. That entry corresponds to that. This entry corresponds to that. That entry corresponds to that. That's what we mean by corresponding. So this A and A is equal to B. This one being corresponding entries are what? Are equal. That's what we mean by what? Corresponding entries. Now that you've known these definitions, now that you've known these definitions, let us look at the main interest of this topic today, which is the transpose of a matrix. Okay, we move on to the transpose of a matrix. Now, what is a transpose? All right. So, a transpose of a matrix, transpose, is denoted by, let's say you have A as a matrix, right? Then there will be a capital letter T on top there. Once you see any matrix raised to the power T, it means that is a transpose. Now, what does it mean to transpose? To transpose just means to swap. You swap what? You swap, or you can say you interchange. You can swap or you can interchange what? The rows and what? And columns. That's what transpose of a matrix is. If you've been given a matrix, you just interchange. Rows become what? Columns. So rows become what? Columns. That's what to transpose is. Let's look at this example. Let's look at this example, practical example. Let's say I have a matrix A, which is given by 6, 2, 4, 9, 3, 1. Then I say find AT. To transpose means you change the what? The rows. Now, so AT will just be equal to, this row becomes a column. Are we together? So this row here becomes what? A column. if that becomes a column, it will be what? To be 6, 4, and 3. The same way it is, just take it down. Now, even this one, the way it is, bring it down. 2, 9, 1. Is that difficult? I really doubt if this is really, really difficult. Let's look at another example. Let's look at another example. Let's say you have this matrix. 3, -4. Find A transpose. Now, this is a row matrix, only with one row. Alright? So this row becomes a what? A column. Alright? What if you have matrix B equal to 4, 9? Then what will be your B transpose? This column, since this is a column, becomes a row. I think this is clear now. This is what? Clear. Now, I want to give you an example on equal matrices. An example of equal matrices. Let's look at an example on equal matrices. Okay? So if, let's say, given that P is equal to 2x, then 6, then 4, then negative 4y, and Q is equal to 8, okay, 6, I maintain my 4 there, and I'll put my 12 here. Okay, find x and y if P is equal to Q. Now, I talked about equal matrices and I gave you a definition, and I said matrices are only equal if the corresponding entries are equal. So we are saying P is equal to Q. Let us write that in form of these matrices. So what is P? P is 2x, 6, 4, negative 4y. And they're saying this is equal to what? 8, 6, 4, 12. This should be simple now, right? And I said corresponding entries are equal. So this entry corresponds to that. So we are saying 2x is equal to 8. This is our equation number 1. This corresponds to that. Negative 4y corresponds to what? 12. What do we get here? You divide by 2, you divide by 2. And x is 4. You divide by negative 4, you divide by negative 4, and your y is equal to negative 3. You have to prove that when I put x there and y there, I'll get the same matrix as Q. Is it giving us the same? Use another color. So where there's x here, if I put 2, what do I get? I get 8. I'm making matrix A. Then I'll maintain the 4, I'll maintain the 6. If where there is y, I put negative 3, and there's a negative there, give us what? 12, which is equal to this, right? Exactly. So this is another example I wanted to give you on equal matrices. I'll give you work on this, so make sure you submit on time.